Hello students, I hope you all are fine. So students, today we will discuss about the some PYQ, okay, previous year questions and some important questions in multiple form, okay. So we will of unit 9, that is amine, okay. So students, let's see about the first question. Today our first question is, what is the most basic aromatic amines common name? Aromatic amine. Aromatic amines means benzene ring is there. Aromatic amine means benzene ring will be there. Aromatic means benzene ring will be there. Not only benzene ring, beta, means which are following Huckel rule, which are having alternate double single bonds. These are the properties of for aromatic. But we are discussing about the aromatic amines. So basically, we are doing for benzene ring. Okay. So here, amine means NH2 group. So what is the most common name for this? What is the most common name for this? Let's see. Benzene amine? No. Benzene amine is not. Benzyl amine? No. Benzyl amine not this. Aniline? Yes. So most commonly it is known as aniline. Aniline. Our question is that what is most basic aromatic amine common name? So this is aromatic amine C6H5NH2 and its common name is aniline. Aniline is the correct option for this question. I hope student this question clear to you. Now move to question number 2. When acetamide is converted to methylamine, what is name of the reaction? Friedel-Crafts reaction, Hofmann reaction, Hofmann-bromamide degradation reaction, Hinchberg reaction. Yes, students, I hope you all know very well when we have any amide like this, when its bromination we do in basic medium, either NaOH or KOH we can take. Then students, what will happen? Simple, with trick, you will remove this group only. Okay, and as it is you will write. Only trick I am telling, not about mechanism. Now, RNH2 plus KBr plus water, these will be removed there. And students, because here one carbon is degrading, is becoming less. So that's why it is known as Hofmann bromamide degradation reaction, because it was given by Hofmann. That's why it's known as Hofmann. Brom, we are using bromine here. Amide, we are using amide also. And one carbon is degrading. One carbon is becoming less. That's why it is known as degradation. So Hofmann bromamide degradation reaction is correct option for this question. Actually, what will happen if you have acetamide? Acetamide means CH3CONS2. Acetamide means CH3CONS2. Okay, when you react with bromine in basic medium, then student, basically what will happen? By trick, you will remove this group only. and you will get CH3NH2. CH3NH2. Okay, so here you are having acetamide. Here you are having acetamide. Acetamide. Or you can say ethanamide because 1, 2, 2 carbon, ethanamide. Okay, but here you are not getting ethanamine. You are not getting ethanamine. You are getting methanamine. Methanamine. Okay, so one carbon is becoming less there. Okay, loss of one carbon is taking place. Loss of one carbon taking place. Okay, that's why it is known as Hofmann bromamide degradation reaction. Hofmann bromamide given by Hofmann, bromine and amide we are using. One carbon is becoming less, and by compiling all these points we can say Hofmann bromamide degradation reaction. So students, right option for this question will be Hofmann bromamide degradation reaction. I hope this question also clear to all students. Now move to next one question, question number 3. Our question number 3, student, for which of the following is Hinsberg approach used? Hinsberg reagent. Student, Hinsberg reagent is this benzoyl sulfonyl chloride. This one is Hinsberg reagent. Hinsberg reagent. Okay. Then students, why it is used? For preparation of primary amine, for separation of amine mixtures, preparation of tertiary amine, preparation of secondary amine. It is not used for preparation, student. First point I want to clear to you, it is not a method for preparation of amine. It is the chemical property of amine. Okay, so you can't go with these options, preparation. You can't go with that option. But it is used for the separation of the primary, secondary and tertiary amine. Okay, so it is used for separation of amine mixture. Option B will be the correct option. Okay, how does it work? Now we will see how does it work. So this is the Hinsberg reagent. When students it react with primary amine, primary amine means any RNH2. So I am writing like this, RNH2. In this way I am writing. Okay, very simple to write the reaction, student, very simple. I am telling about tricks only because here we are doing MCQs. Okay, so student, what will happen? HCl you will remove HCl. Okay, then you will get sulfonamide. Benzene, S double bond O, then NHR. Sulfonamide. Okay, then student, if this react with alkali means either NaOH or KOH, then student you will get soluble salt here. If this product which you get after reaction of Hinsberg reagent with primary amine, if you add alkali in this product, then you get soluble salt. Okay, then student you get the soluble salt. In what way? This and because alpha hydrogen is here, because alpha hydrogen is there, okay, and it is more acidic, it is acidic, okay, due to presence of the alpha hydrogen, it is acidic. Then students, what can you get? Water can be removed, water can be removed, and you can get N negative, Na plus R. This soluble salt you can get, this soluble salt you can get. So what will happen, student? If you are having Hinzberg reagent and you are adding primary amine in that, you are adding primary amine in that, then students, the product, this sulfonamide you will get, it can dissolve in alkali and you will get the soluble salt, you will get the soluble salt. Okay, why it is getting soluble salt? Because after becoming product also it is having alpha hydrogen, it is having addition acidic hydrogen. But student, if you are reacting this Hinzberg reagent with secondary amine, with the secondary amine R2NH, then what will happen? In same way, HCl you will remove. In same way, reaction procedure is same. You will remove HCl and product you will get like this, S double bond O NR2. Now student, this product you get, okay. Then after this, if you add alkali in this, you add alkali in this, then student, you do not get any product, no soluble salt you will get here. Why? Because it is not dissolving in alkali due to absence of alpha hydrogen. Here alpha hydrogens are zero. Alpha hydrogens are zero. No alpha hydrogens with this nitrogen. So that's why it is not reacting further. It is not further dissolving in NaOH. Okay. So students, if you are having any amine and you are adding Hinzberg reagent in that, then you will get one product. Okay, then you will add some aqueous NaOH in that. If you are getting that product is soluble completely, you are getting soluble salt, so okay, means your amine is primary, otherwise it is secondary. Okay, but if you are having tertiary, if you are having tertiary amine, then student, it is not having no alpha hydrogen, it is not having any alpha hydrogen initially also. Okay, so initially it is not reacting with this, initially it is not reacting with Hinzberg reagent. Okay, so if you are adding Hinzberg reagent and no reaction is taking place there, means your amine is tertiary. So students, in this way, Hinzberg reagent is used for separation of the primary, secondary and tertiary amine. Primary, secondary and tertiary amine. Okay, it is not used for the preparation of amine. It is not used for preparation of the amine. Neither it form primary nor secondary nor tertiary. Okay, but it separate the mixture of the primary, secondary and tertiary amine. So here option B will be the correct option. Here option B will be the correct option. I hope student this one question also clear to all the students. Now student, our next question, which of the following is formed when alkyl primary amine react with nitrous acid? You are having alkyl primary amine, you react with nitrous acid, then what will you get? Students, actually what will happen, if you are having any alkyl primary amine, For example, if you are having methylamine, okay, methylamine. So here alkyl group also it is primary amine also. If you react with nitrous acid, student, nitrous acid you will make with C2 mechanism. C2 mechanism means during the reaction you will add sodium nitrite plus HCl. Sodium nitrite plus HCl. Then during the reaction it will form by double displacement reaction and you will get NaCl plus HNO2 plus HNO2. Okay. So student, this HNO2, this one is the nitrous acid. This one is the nitrous acid. This one is the nitrous acid. This nitrous acid, student, you will make with C2 mechanism. Okay, during the reaction only you will make. So you will take primary amine, you will add some NaNO2 and HCl. Okay, so during the reaction formation of HNO2 will take place there. Student, you will take temperature around 0 degrees Celsius to 5 degrees Celsius. 0 degrees Celsius to 5 degrees Celsius. Then what will happen? You will get alkyl disonium chloride. Alkyl disonium chloride. Here methyl you are having, so you will get methyl. This group is diazonium. Diazonium chloride. Student, this one is very least stable. This one is very least stable. Alkyl disonium chlorides are least stable. Okay, even they are not stable at very low temperature, at very cold temperature also. If you are having benzene disonium chloride, if you are having benzene diazonium chloride, then it is stable at cold temperatures. Okay, but your alkyl disonium chloride is not stable even at cold temperatures. So easily what will happen? Very fastly it react with some water and it gives us alcohol. It gives us alcohol. Here you will get this. Okay, respective alcohol you will get. So student, now I hope you all know. So first, if you are having primary amine, if you are adding nitrous acid, okay, you will make with C2 mechanism, then it gives disonium chloride, but this disonium chloride is very less stable, so it gives us alcohol. It gives us alcohol. So I hope this is clear to all the students. So student, here correct option will be option D. Correct option will be option D. That is the alcohol. That is the alcohol. Then your next question is, which of the following is a tertiary amine? Which of the following is a tertiary amine? Students, amine, you are having nitrogen, okay? If one R group is there and two hydrogens are there, and if two hydrogens are there, then it is primary amine. Then it is primary amine. Okay, it is primary amine. And if two R groups are there, and only one hydrogen is there, it is secondary amine. It is secondary amine. And if no one hydrogen, all are the R groups are there, then it is tertiary amine. Then it is the tertiary amine. Now you will say, ma'am, if all are hydrogens, then student, then it is ammonia. Then it is known as ammonia. Ammonia. Okay. So students, here you will see tertiary amine. He is asking about tertiary amine. So simply where three R groups and one nitrogen. And simply I can tell you, if NH2 group is there, it is primary. If NH group is there, it is tertiary. If only nitrogen is there, then it is tertiary, then it is tertiary. Then student NH2 group, it is primary, it is primary. Then NH, it is secondary, and two methyl group also there. Yes, N, so it is the tertiary, it is the tertiary, and NH2, this is the also C6H5NH2. So it is also primary. It is also primary there. So student, option C will be the correct option there. Option C will be the correct option. This is the tertiary amine. This is the tertiary amine. Simply you can see, if NH2 group is there, it is primary amine. If NH group is there, it is secondary amine. And if only nitrogen, then it is tertiary amine. Next one question, the nitrogen. Okay, so student, how can you tell about the hybridization? Hybridization means lone pair plus bonded atoms, plus bonded atoms, bonded atoms. Okay, so you can see here bonded atoms in any, either in primary or in secondary or in tertiary or in ammonia, in any you can say bonded atoms are 1, 2, 3. Okay, so bonded atoms are 3 plus one lone pair is there, one lone pair is there in all. So this sum is 4. If this sum is 4, then student, hybridization is sp3. Hybridization is sp3. Student, they have sp3 hybridization. Their geometry is tetrahedral. Their geometry is tetrahedral. Their angle is slightly less than 109 degree 28 minutes. It is less than it due to presence of lone pair, around 108. Okay, in ammonia it is 107, but in this it is around, in tertiary it is around 108 degree. Okay, then student, their shape is pyramidal. They are having pyramidal shape. They are having pyramidal shape. Their shape is pyramidal. Their shape is pyramidal. Okay, but he is asking about hybridization only. So hybridization is sp3. sp3 given in option? Yes, in option C given. So your option C is the correct option for this. Your option C is the correct option for this. I hope it is clear to all the students. Now students, our next one question. Which method is best for preparing primary amine? Best for preparing primary amine with one carbon less, than the starting amide. Already I discussed, students, one carbon less, and we are making amine from amide. Okay, so that reaction is Hofmann-bromamide degradation reaction. Further, I will not explain the reaction. Already I have explained about Hofmann-bromamide degradation reaction. This is the reaction. You can see, if you are having amide, student, okay, you react with bromine in presence of basic medium, then you will get one carbon less amine, and this reaction is known as Hofmann-bromamide degradation reaction. Okay, so already I have explained this reaction. So student, further I hope need not to explain this. So ammonolysis of alkyl halide, no. Hofmann-bromamide degradation. Correct option is Hofmann-bromamide degradation reaction. You will go with option B. Then student, your next question is question number 8. The Hinzberg reagent. Okay, I hope this question you also able to solve. The Hinzberg reagent is used to differentiate between primary, secondary and tertiary amine. Already I told, beta, Hinzberg reagent is used for separation of mixture of primary, secondary and tertiary amines. On solubility of resulting sulfonamide. Yes, on solubility of resulting sulfonamide. If you are having primary amine, so its resulting sulfonamide will dissolve in alkali. If you are having secondary amine, so its resulting sulfonamide will not dissolve in alkali. Okay, and if you are having tertiary, so initially it do not react with Hinzberg reagent. Which amine does not react with Hinzberg reagent? Already I told now. Tertiary amine beta. Tertiary amine initially do not react with the tertiary amine. Tertiary amine initially do not react with Hinzberg reagent. So your answer will be tertiary amine. Your answer will be tertiary amine. Then students, next one question is, which of the following is the most preferred reagent for reducing nitroethane to ethyl amine? You are having nitroamine, not amine, nitrobenzene. You are having nitrobenzene. Sorry. Nitroethane. You are having nitroethane. Benzene also not there. You are having nitroethane. You are having nitroethane. Okay. You want to make ethylamine. You want to make ethylamine. Ethylamine. You are having nitroethane. Nitroethane. You want to make ethanamine. Which one is the most stable, most preferred reagent here? Student, for reduction of nitro group into amine, basically you can use three reagents. One is Sn plus HCl, second one is Fe plus HCl, third one is hydrogenation, H2PT. Okay, this reaction given in your NCERT also. This reaction is given in your NCERT also. These three reagents you can use. But student, this one reagent, Fe plus HCl, this one is most preferred reagent. Why is it? It is the most preferred reagent. This one is most preferred reagent. Why is it? Because student, here we need this HCl for initiation of reaction only, in very small amount. We need this HCl in very small amount. In very small amount, only for initiation of reaction. Only for initiation of reaction. Because we need this HCl in very small amount only for initiation of reaction. Further it produced during the reaction. And that HCl can be used for further reaction. Okay. So student, that's why this one, FeHCl, this is the most preferred reagent for reduction of nitro into amine. So your option C will be the correct option for this. Your option C will be the correct option for this. I hope this question clear to all the students. Now student, your next one question. Your next one question is, which of the following reagent would not be good choice for reducing any aryl nitro compound, okay, to an amine? So already I told these are the good choice: Sn plus HCl, Fe plus HCl, H2 and Pt. If you have any other option, then that will be the correct option for this question. H2, Pt, this is used for reduction. LiAlH4, it is not used. FeHCl you use, SnHCl you use. So he is asking about not. So your correct option will be option B. Option B will be the correct option for this question. I hope student all questions are clear to you. I hope all questions are clear to you. Okay, so today we have covered 10 questions in very explained way. I hope all questions are clear. You will do these questions in your fair notebook. Okay, that is your homework. So thank you. Have a nice day.